All right, so again, this is y equals mx plus b form, right? Slope-intercept form. So we're going to substitute 3 for the y, -5 for the m, 1 for the x, and then plus b, and then solve for b. So we'll multiply the -5 times 1, and then we'll add the 5. So we get 8. So our answer, our equation of that line is y equals -5x plus 8. We'll substitute the 8 in for the b. Simple, right? That's what we're working on the first 6, and then the other 6 was just putting it in point slope form, which was just substituting. Morning, Cole. Thank you. All right, so, oh, you know what? I didn't do my homework. So you guys are going to have to tell me the answers. Forgot I didn't have the answers already done. All right, so what's number 1, Brooke?
Y equals 2x plus 1.
Y equals 2x plus 1. You guys agree with her?
Yeah.
Okay. All right, number 2, how about Cindy?
I got y equals 3x minus 10.
You guys agree? 3x minus 10? If anybody has any question, let me know. We'll go over it. Number 3, Brock.
I got y equals 1/2 x plus 4.
You guys agree? No? Somebody else have something different? Jordan?
Y equals 1/2 x plus 2. That's what I got.
Plus 2. More,
I think I'm wrong.
what'd you get?
Plus 5.
Plus 5? All right, we have a couple plus 5s too. Let's go over that one. That's good. All right, so we've got
I got y equals 2.
1/2 x plus b, and the point's -2, 3, right? So 3 equals 1/2 times -2. What happens to the 2's? Cancel, right? That's an easy multiplication. So that's, they cancel, that's a -1, right? So then I'm going to add the 1. So it should be plus, what's 3 plus 1? 4. So it should be y equals 1/2 x plus 4. Did anybody say that? Yes. Did you say that, Spence?
I mean, I got that for 3.
We are on question 3, right?
I thought we were on 4.
Oh, did I say 4? No. 3, right? Yes. Then, why is that a -1? Yeah, from the -2. It's a positive 1/2 times a -2, so it's a -1. Okay? Any other questions? All right, good. Number 4, Emma.
Y equals 2/3 x minus 9.
You guys agree? -9. No discrepancies there? Okay. I'm taking your word for it. Number 5, Callie Wilson. You just substituted in, didn't finish?
Yeah.
Okay. Landry? Mason?
Are we on number 5?
Yes.
Y equals -1/4 x minus 3.
-3. You guys agree?
I got mine.
I got one.
Yeah, that's one. Probably right.
All right, let's go over that one. All right, so the slope was -1/4, and the point was 4, -2. So it's going to be y -2 equals m x, which is 4, plus b. So the 4's cancel again, right? So what's that answer? -1. So we're going to add 1, and we'll get -1 for b. Right? So it's y equals -1/4 x minus 1. All right, the last one of those, Taylor Miller.
Y equals -2/7 x minus 5.
-5. We agree?
Yeah.
We got some. All right, let's look at that one just to make sure. So this one, m was -2/7, and our point was -7, -3. So it'll be -3 for y equals m, -2/7 our slope, and then x was -7, and then plus b. Now I have a negative times a negative. So when those cancel, what happens to the 2? +2. Oops. Equals 2. So I'm going to subtract 2. What's a -3 and a -2? -5. Why did I make that a 6? All right. So -2/7 x minus 5 in slope-intercept form. Questions? Is that making sense? Okay. So some of our mistakes are probably just the negative sign, right? You gotta pay attention to those little details. All right. They made it easy for us because they always made the number, the x number, the same as our denominator, didn't they? That's not always going to happen, though, is it? All right. For number 7, we're just substituting into the formula, right? So it's y minus 1 equals 5 times x minus 1, right? And then y minus 4 equals 2 times the quantity, x plus 3, right? Because it's minus a -3. And number 9 is y plus 3, minus a -3 equals 3/2 m times quantity x minus 6. Questions? Number 10, y minus 7 equals 2/5 times the quantity x minus 5. And then 11, y minus 5 equals -3/4 times the quantity x plus 4, minus a -4. And then y plus 3 equals -3/8 times the quantity x plus 2. That was too easy, huh? All right. Good practice to get us going. What do we call that way we were doing 7 through 12? Point slope form. Good. All right. Today we are going to talk about solving a system of equations. A system of equations, a system of linear equations, is a set of 2 or more linear equations in the same variables. All right, so we're going to look at an example here. It's actually below, not at the right. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. And if you turn over that paper I gave you yesterday, that's just what it says, what we're doing. Okay, I just kind of spread it out on my slides. Okay, so when we have a system of equations in two variables, there's two answers. We need to find the x answer and the y answer. Okay, there's three different ways we can solve these. We can solve them by graphing. Graph the two linear equations, which is two lines, and see where they intersect. We can use a method called substitution, and another method, the third way, elimination. So we're going to do all three with the same problem. You'll see we'll get the same answer each time. So there's our system. X plus 2y equals 5, and x minus y equals negative 1. All right? And doing it graphically, I like to get y by itself. So x plus 2y equals 5. To get y by itself, what do I do first, Sophia?
Wait, get 5 by itself?
The y by itself.
X.
Yeah, subtract the x. Very good. Because I'm going to put it in slope-intercept form. When you get y by itself, then you have it in slope-intercept form. And then we can graph using the slope and the y-intercept. So I like to put the x in the front. But if you put 5 minus x, that's not wrong. That's all right. You can do that. You don't like the tater tots?
No, I
That's
want
okay.
the axis for it.
And then what do I do with the 2? Nolan?
Do you divide it over?
Yeah. So here's what we got to remember when we divide it over, is that we divide both of these terms by 2. Sometimes we forget to divide the 5 by 2. So I get y equals, and what number is in front of the x? It's just not written. 1. So this is a negative 1/2 for my slope, x, plus 5/2. Okay? We're going to do the same thing for the other equation. To get y by itself, Spencer, what do I do first? Yep, subtract the x. And this is negative y still. So, Nick, what would I do now with that negative 1?
Would you add y?
Well, this means negative 1 times y. So when I go to the opposite side, I'll do the opposite. The opposite of multiplying.
Divide.
Yeah, so I divide by negative 1. That's what we do with the 2, right? That's 2 times y. So the opposite, going to the other side, or the opposite side, we're divided by 2. So I get positive y, and positive x, and a positive 1, right? Negative divided by negative is positive. So there's my 2 equations in slope-intercept form, all right? The b value is the y-intercept, where it crosses the y-axis, and then the m value in front of x is my slope, right? So I go to, what is 5/2? Where's that on the y-axis? What number is that? 5 divided by 2. 2.5, isn't it? So we're going to go up the y-axis 2.5, and then from there go where? Who said that? Emma, what did you say?
1 over 2.
Up 1? We go right or left 2?
Oh, right.
Left, because it's negative, right? Negative slopes this way. One of those numbers has to be negative. It doesn't matter if you make the 1 negative or the 2 negative. Just one of them though. Because if you made them both negative, what did you just turn it into? A positive. Then it would be this way, right? All right. So it doesn't matter. You could go up 1 and left 2, or down 1 and right 2. Okay? here where we start? At 1. Then where do we go?
1.
Up 1 and over 1, right? Up 1 and right 1, or down 1 and left. You could do 2 negatives. Okay? So the picture's over here. That's why I didn't just do it. Oops. Gotta go to this, huh? Now that's in the way. Gotta get that out of there. All right. So here's that 2.5, right? The first one. And then we went down 1 and over 2. Down 1. I should use my pen. We'll do the red dots for it, because that was the red equation. So here's our y-intercept, and then down 1 and over 2, here's another point. Down 1 to half, and over 2 to the 4th. Down 1 to negative a half, and over to the 6th. That's that line. And when you do it graphically, you got to be really, you need graph paper, and you need to be really neat so you get that line right where it needs to go, right? Got to be really accurate. Then here's our 1, we'll do the blue. Here's our y-intercept, and then up 1 and over 1 are those spots. And then where you see the 2 lines intersect is the solution to the system. That means that 1 for x and 2 for y, when I plug in to both equations, it gets the right answer. 5 for this one and negative 1 for that one. It's the solution to both equations, so it's a solution to the system of equations. You guys remember that?
Hardly.
Hardly?
Mm-hmm.
Well, now you do. You got it, right?
Yeah, totally.
Okay? Make sense? So that's one way to do it. Okay? Another way is by substitution. Okay? When you do substitution, you get one of the variables alone. It's your choice. Now, I will tell you, I would look to get a variable alone that has no coefficient. What's a coefficient? Nobody knows? Gotta know our vocab for algebra. Coefficient is the number in front of the variable. So what's the coefficient of that x? 1. That one? 2. This one? This one? That one. So I would get either one of the x's, or you want a 1 for the coefficient, or no number in front. You can get the 2 by itself, but to move the 2 over, what are you going to have to do? What happened when we moved this 2 over? What did we do with it? We divided, right? It's the same 2. It's the same problem. Okay? Then we're going to get a fraction. We're going to get that 5 halves, right? You like working with fractions? No, most people don't. So that's why I say get a variable that has no number in front alone. So Gabe. No, not Gabe. Geyer. Cole Geyer. Cole. Which one of these variables would you like to get alone?
Y.
Okay, you want this y alone? Okay. So we're going to subtract x. We're going to divide by negative 1. We always want, when we get an x or a y alone, we want it to be a positive x or y. And that's a positive x and a positive 1. All right, so he said to get that y by itself. And again, it's your choice. And then you take this and substitute it into the other equation for that variable. So I'm going to take this, x plus 1, and substitute it for the y in the other equation, because that's what y equals. That's using substitution. All right, so this is x plus 2 times x plus 1 instead of the y equals 5. So what do I have to do with that 2?
Distribute.
Distribute. You guys all know the distribute property, right? You're supposed to. So x plus 2x plus 2 equals 5. When I distribute the 2 times x and 2 times 1. And then I'll get 3x, x plus 2x, combining like terms. And then I'll get x by itself. So I'll subtract 2. And divide by 3. Whoa. Doing that already, huh? So I get x is 1. Am I finished?
No.
No. What did we get for an answer when we did it graphically?
A line.
Yeah, a point where the 2 lines intersected. What was that point? 1, 2, right? So I got to get that 2 part, the y equals 2 part. So what I do is I take this and I put it right there so I can find the y. So we still get that point, same answer, where they met when I graphed them. Any questions on that? You're supposed to know how to do that already. Remember from Algebra 1, according to this book. That's why we're reviewing. Questions? Get it? Got it? Good, right? Good, better, best. Don't let it rest till your good is better and your better is best, right?
Sure.
Taylor, you read that every day when you come in here, don't you? Yep. I thought so. That's what you do in basketball too, right? You play volleyball too?
No, I just got your check.
Soccer. All right. Any questions on substitution? All right. What's the third way to do this problem? Elimination. Okay. What answer should we get again? 1, 2. Right, Mace? Okay. So we got elimination. Right. In this method, you eliminate one of the variables. All right. In order to eliminate one of the variables, you need to get the same coefficient in front of one of the variables. And again, it's your choice. Now, I would not do what your book, your little paper does. Your paper multiplied the bottom equation 2 by 2. I wouldn't multiply any of them, because what's in front of both x's? 1. They already have the same number in front, right? So that step you don't really need to do, but you can. All right? Once you look to eliminate one of the variables, and again, it's your choice to eliminate which one you want to eliminate, but save yourself some work. Look and see if either one of them has the same number in front. If they do, then that step you don't have to do, that multiplication. Sometimes you got to multiply both equations by a number. Like if I wanted to make the y's both a 6, I'd have to multiply the top equation by 3 and the bottom equation by 6. But you can do that. You can make them whatever you want. But to save yourself some time, this one's already ready to go. All right. When you do this method, you want to make sure your x's are lined up, your y's are lined up, your equal signs, and then your constants. We call those number by itself. We call it constant, like it is. Sometimes they won't write it all lined up for you. Because what we're going to do is we're going to add or subtract the 2 equations. Okay? Now, in order for these x's to go away, to be eliminated, should I add them together or should I subtract them? You should subtract them, right? Because what's 1x minus 1x? 0, right? You want 0 x's. or 0 y, depending on which one you're eliminating. If I were to add those two, I'd get a 2x, right? 1x plus 1x. So here's what I tell kids. If the signs of your coefficients are the same, these are both positive, right? You subtract the two equations. S for same signs, S for subtract. If I would have made this a 2, then that's a positive, that's a negative. For those to be eliminated, I would have added them. And that's how, on the paper, it does it for you, I believe, doesn't it? I think it made it a 2. I think it made it 2x minus 2y equals negative 2, didn't it? Okay? So again, signs the same, subtract. So we're subtracting. Well, again, what's 1x minus 1x? 0, nothing. They are eliminated. And then what's 2y minus negative 1y? 3y, yeah. And what's 5 minus negative 1? 6. So now you have an equation with one variable that you can solve. Divide both sides by 3. You get y equals 2. Now what do I do to figure out the x? Substitute in, right? Does it matter which one, top or bottom, that I substitute in? No, again, that's your choice. Let's just do the top one. So this is going to be x plus 2 times y, which we figured out to be 2, equals 5, which is x plus 4 equals 5. And solve for x, get x by itself, and we get the same answer, which is what we're supposed to get, right? Same problem, same answer. Just 3 different methods. Any questions on graphing or substitution or elimination? You understand? All right. So your homework, good job. Thanks for your attention. Your homework is doing those problems at the bottom of that side of the worksheet.
Is that the